Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as electrons and photons. Can you just draw this diagram first? Draw the diagram please. Right, now let's see this diagram guys. Everyone's finished drawing the diagram? Let's see the diagram. Now they've given you that, let's see this. This is how your oscilloscope, or this is how your discharge tube is. Here you have a cathode which is given extreme high negative voltage. You have anode here. Now because of extreme high negative voltage, you have a stream of electrons given out from here. These stream of electrons are passed through two plates, right, which have a small hole in the center, so that you can have an extreme thin stream of electrons. The plates are connected to positive terminals, that is the reason why they attract electrons. Fine. And then it is made to fall on a phosphorus screen. Here you have another two plates which have been given positive charge, positive and negative charge. Fine, do we get this in here? So that's your entire arrangement that is used. Now the reason why we are doing this is how Sir J.J. Thomson discovered electron. The discovery of electron, what is the charge on electron, what is the mass on electron, was discovered with the help of this experiment. Now we'll see how. So here you have a discharge tube. This is the experimental arrangement which consists of the discharge tube containing a gas at extremely low pressure. The cathode is at one end, and you have electron beam which is propagated to the other end. Fine. Electrons which are emitted from the cathode are attracted by the anode, and that's the reason why they start moving ahead. Then again positive D1 and D2 have positive charge which pulls the electrons ahead, and by now they have sufficient velocity to go and strike the phosphorus screen at the center. Right? Now you have plates D1 and D2 which have been given positive charge. Now since D1 and D2 are given positive charge, they push the plate ahead, they push the electrons ahead. Then similarly you have plates C and D which have been given positive and negative charge. They have been connected to a DC source. Now since they have been connected to a DC source, electric field is generated here. You have a strong electric field that is generated. Now since plates C and D are perpendicular to the stream of electrons, therefore they produce an electric field that will deflect the electron in the vertical plane. C and D will deflect the electron in the horizontal plane. D1 and D2 will deflect the electron in the horizontal plane, and C and D will deflect the electron in the vertical plane. Now let us exactly see how much deflection takes place and how it takes place. Right? Now, this is your plate C, this is your plate D. Right? You have an electric field that is produced. You have the electron stream that is passing from the center. Right? You have positive charge on one plate and negative charge on the other plate. Now we know that electron beam is negatively charged. Since you have positive charge here, what will happen after a certain point of time? The positive charge will attract the electron beam, therefore the electron beam will be deflected upwards in the vertical plane. Right? Now let us consider that the strength of the electric field that is pulling the electron up, the electron beam up, is say Fe. That's the force of the electric field. And let us assume that the electric field that is present here between the positive and the negative charge is say capital E. Right? In that case, the force that will be acting on the particle, on the electron beam, Fe, the force that will be acting on the particle will be nothing but E into E. E is the charge on the electron, and capital E is the strength of the electric field that you have here, or intensity of electric field. Fine? Where you can say that E is nothing but the charge on the particle and capital E is the intensity of electric field. So thus plates C and D produce an electric field that pulls the electron beam in the vertical plane, which can move the electron beam in the vertical plane. Now besides that, you have plates D1 and D2. Plates D1 and D2 produce a magnetic field. Both are being given positive charge, so they produce a magnetic field. Now the magnetic field that is produced by them This was the electron beam that was moving here. Now because of the magnetic field, because of the deflection, when you have a charged particle, moving in the presence of another charged particle, that results in a torque. Now because of this torque, what will happen is that the electron beam is going to get deflected. Instead of moving straight this way, it is going to get deflected. There is going to be a downward force that will be acting on it, right? At this point, let's draw a circle at this point. Let's assume that R is the radius of this circle. Fine. This is going to be the force with which it is going to be pulled downwards. Let's call this as, say, FB. Right? Magnetic force. So the magnetic force with which the electron beam is going to be pulled in the horizontal plane, this is your horizontal plane, is going to be given by BeV, right? Where B is the magnetic induction, E is the charge on electron, and you have V is the velocity with which it is moving. Right, we will write this V as this way. Generally we write velocity that way. Right? Now, so there are two forces that are acting here. One which is going to pull the magnetic field downwards, one which is going to pull the magnetic field upwards. Now these two forces, if I want to keep the magnetic field at the center, the two forces should be equal. If I want to produce a dot right at the center of the screen, the two forces should be equal. So in order to produce a bright spot at the center of the screen, the two forces have to be equal. That means I should have, in order to produce a bright spot at the center, FE should be equal to FB. FE is going to be E into E. FB is going to be nothing but BeV. E and E gets cancelled. This is velocity, right? E and E gets cancelled. Therefore, the velocity of the electron is nothing but the strength of the electric field upon the strength of the magnetic field. Fine. That's how you find out the velocity with which the electron is moving. Now, the electron was pulled downwards. If you look at the magnetic field, the electron was pulled downwards. There was a force that was pulling it downwards. Let's assume that this was that field, this was that magnetic field that was pulling the electron downwards. Now in that case, if the magnetic field is in the form of a circle, that means there must have been some circular force that must have been exerted on the electron. If there is some circular force that is exerted on the electron, that circular force must have been formed due to the centripetal force. If the force is in the form of circle, it must be due to the centripetal force. So the magnetic field is produced due to the centripetal force. The magnetic field that is going to be produced here is going to be due to the centripetal force. I can say that if m is the mass of the particle, if m is mass of particle and r is the radius, then I can say that the r is the radius of the circular path. Then I can say that the centripetal force is equal to the magnetic force. Centripetal force is nothing but mv square by r, right? Magnetic force we found out is nothing but BeV. So in which case you can say that V square, and this will get cancelled, so I will get V upon R, V upon BR is E upon M, right? Therefore, the ratio of E upon m is equal to V upon Br. V is the velocity, B is the magnetic induction, R is the radius of the path. Since all these values are known to us, we can easily find out the ratio of E upon m. The ratio of E upon m by putting in these constant values comes out to 1.7589 into 10 raised to 11 coulombs per kg, right? So this is how J.J. Thomson found out the ratio of charge on the electron to the mass on the electron. Later, the charge on the electron was discovered as 1.6 into 10 raised to minus 19 coulombs. By substituting that value in E, the value of mass of the electron was determined. This is how the mass of the electron was determined. We've done this experiment to find out the mass of the electron. Fine. Can we just write this down quickly, guys? Take down the question for this, please. Explain Thomson's experiment. Explain Thomson's experiment. Write the theory for the experiment. The experimental arrangement consists of a discharge tube. The experimental arrangement consists of a discharge tube containing gas at extreme low pressure, cathode emits cathode particles. Which are accelerated towards metal disc D1 and D2. And emerge out in the form of a narrow beam. The beam then travels in a straight line. To produce bright spot O. The beam then travels in a straight line to produce bright spot O. Sorry. Now once you've done this, right, C and D are two metal plates through which the beam passes. C and D are two metal plates through which the beam passes. C is connected to a positive terminal. Thus, an electric field is produced which is directed vertically downwards. Thus, an electric field is produced. Thus, an electric field is produced which is directed vertically downwards. As the electrons are negatively charged, negatively charged, they are directed vertically upwards. As the electrons are negatively charged, they are directed vertically upwards by the electric field. A uniform magnetic field at right angle to the plane, a uniform magnetic field right angle to the plane and directed inwards is applied using an electromagnet. Which deflects the beam in downward direction. Right, in the electric field, or due to the electric field, Fe is equal to E into E. Guys, see this. Due to the electric field, Fe is equal to E into E, where E is the charge on the particle and capital E is the intensity of the electric field. Where E is the charge on the particle and capital E is the intensity of the electric field. And this is how the beam is, guys, see this. This is how the beam is directed. You've already seen this. Leave space for copying this diagram. Then move on ahead. Right, also in the magnetic field, or also due to magnetic field, FB is equal to BEV. Also due to magnetic field, FB is equal to BEV, where B is the magnetic induction, E is the charge on electron, and V is the velocity at which the particles are moving. Right, leave space for copying this diagram, guys. Now, right, by changing the electric and magnetic field, the bright spot is produced exactly in the center. By changing the electric and magnetic field, bright spot is produced exactly at the center. This is possible only if the Fe is equal to Fb. This is possible only if Fe is equal to Fb. This is possible only if Fe is equal to Fb, because Fe was pushing the particle upwards, Fb is pushing the particle downwards. If the bright spot, if the beam is traveling in a straight line, that means the upward force is equal to the downward force. Now we've already found out the value of Fe and Fb, right? Therefore, E into E is equal to BeV. Thus, V is equal to E upon V. Thus, the velocity with which the particles move, right? Thus, the velocity with which the particles move is directly proportional. The velocity with which the particles move is directly proportional to the strength of the electric field and inversely proportional to the strength of the magnetic field. Right. Also, when the particles move in the magnetic field, also, you want me to repeat that? Is directly proportional to the strength of the electric field and inversely proportional to the strength of the magnetic field. Right. Also, when the particles move in the magnetic field, the force acts on them. Force acts on them, which is always perpendicular. Force acts on them, which is always perpendicular. Force acts on them, which is always perpendicular to the direction of the motion of the particles. To the direction of the motion of the particles. To the direction of the motion of the particles. This force acts as a centripetal force. This force acts as a centripetal force. Thus, if m is the mass of the particle, and r is the radius of the circular path, then centripetal force is equal to the magnetic force. Therefore, mv square upon r is equal to BeV. Therefore, mv square upon r is equal to BeV. Therefore, V upon Br is equal to E upon m. V upon Br is equal to E upon m. Since the radius of the circular path can be determined, by observing the deflection on the fluorescent screen, by observing the deflection on the fluorescent screen. Guys, see this. I have electric field here, I have magnetic field here, right? Suppose if I switch off the electric field, then there will be only magnetic field and this particle will move here. By just measuring this distance, I can find out the radius. That's what we are saying. So the radius of the circular path can be observed or can be determined by observing the deflection on this fluorescent screen, right? And hence the value of E upon m can be determined. Hence the value of E upon m can be determined as (1.7589) into 10 raised to 11 coulombs per kg. This particular value remains constant. This particular value remains constant irrespective of the material or the gas used in the discharge tube. Right? This finishes this answer. This was Thomson's experiment. We'll stop this here for the day. Thank you very much.